It's almost hard to keep up, isn't it? Just when you think you've got a handle on the latest AI um, advancements, something else groundbreaking comes along,
Yeah,
especially in how AI is fundamentally reshaping software development.
absolutely.
Today, we're taking a deep dive into two, well, really remarkable new models from Anthropic, Claude Opus 4 and Sonnet 4,
Hmm.
both now available on Amazon Bedrock.
Yeah, what's particularly exciting about these releases isn't just that they're, faster or slightly better.
Right.
It feels like a genuine leap in their ability to tackle really intricate problems, especially when it comes to writing code, handling complex reasoning,
Uh-huh.
and even powering what are looking like truly autonomous AI agents. Think of it less as just an upgrade, more like a paradigm shift in what's possible.
Exactly. So our goal today is to kind of get under the hood of Opus 4 and Sonnet 4. What makes them so powerful?
Hmm.
What can they actually do that maybe previous models couldn't quite nail? And crucially, why should this grab your attention? Whether you're a developer wrestling with some, gnarly bug,
Right.
a tech enthusiast just eager to see the future unfold, or maybe just someone curious about how AI is evolving. We're going to try and pinpoint what sets these models apart and explore how you might actually see them being used, in the real world.
Okay, sounds good. Let's start with Anthropic's current flagship, Claude Opus 4. This model really lives up to its name. It's an absolute intelligence powerhouse.
But when they say powerhouse, the benchmarks seem to back that up.
Yeah.
Anthropic's own testing shows Opus 4 kind of leading the field in coding capabilities. Okay, so let's unpack why it's such a coding whiz. What's the secret sauce there?
Well, a big part of Opus 4's strength lies in its ability to manage incredibly long streams of information
Okay.
and navigate these really intricate logical pathways. Imagine trying to understand a massive software project, right? Countless interconnected parts. Opus 4 can kind of maintain that bird's eye view while simultaneously diving deep into the specifics of individual modules. It handles context in a way that, frankly, previous models just couldn't.
So it's not just generating a function here or there.
Hmm.
It can actually understand and work with the entire architecture of a project.
Exactly.
That sounds like it could be huge for maintaining and evolving those really large, complex systems.
Precisely. It's designed for multi-step development workflows. So it can take a high-level goal, break it down into a sequence of actionable steps,
Uh-huh.
and then actually write and refine the code across all the relevant parts of the project. It can even tackle that often daunting task of refactoring existing code while, staying true to the overall architectural design.
Wow.
Think about the potential for reducing technical debt in those sprawling legacy systems.
That's a really compelling thought. And you mentioned its strong performance on specific coding benchmarks. What makes those tests, like SW Bench and TAU Bench, so significant?
Yeah, those benchmarks are specifically designed to evaluate an AI's ability to solve, real-world software engineering challenges,
Right.
from understanding bug reports to writing the necessary code to fix them. Opus 4's exceptional results on these really highlight its aptitude for those complex, demanding development tasks where deep understanding and reasoning are just critical.
Okay.
It can ingest vast amounts of technical documentation, formulate an implementation strategy, generate the initial code,
Mm.
and then iteratively improve it based on feedback, all while keeping the underlying system architecture firmly in mind.
Okay, so Opus 4 is the go-to for those really intricate, maybe head-scratching problems.
Right.
Now, let's talk about its sibling, Sonnet 4. It sounds like it's designed for a different kind of challenge, maybe more about speed and efficiency.
Exactly. Yeah, if Opus 4 is the master strategist,
Hmm.
Sonnet 4 is more the agile and efficient executor. It offers this fantastic balance of strong performance and operational efficiency. Makes it really ideal for high-volume, production-oriented environments. You should consider it a direct and significantly enhanced successor to the previous Claude Sonnet 3.7.
So where does Sonnet 4 really shine then? What are its key advantages for developers in their sort of day-to-day work?
Well, Sonnet 4 excels at those routine yet critical development tasks that happen constantly. Think about performing code reviews,
Mm-hmm.
quickly identifying and fixing bugs, generally ensuring a smooth, continuous development process. Its speed and efficiency also make it incredibly well suited for powering real-time AI assistance,
Oh, interesting.
the kind developers can interact with directly within their IDEs, for example.
Yeah.
Imagine getting instant feedback on your code as you write it.
Ah, okay. So if you need that rapid feedback or you're dealing with a high volume of AI-powered interactions, Sonnet 4 is the more let's say, efficient choice.
Exactly.
That makes a lot of sense for things like automated code quality checks, maybe.
Absolutely. And it's also designed to function very effectively as a specialized sub-agent within larger multi-agent AI systems.
Right.
So, for instance, you might have one AI agent responsible for the high-level planning of a new feature,
Mm-hmm.
and then delegate the actual code generation or automated testing to maybe a fleet of Sonnet 4 instances. It's also well-suited for managing CI/CD pipelines.
Continuous integration, continuous delivery.
Exactly. Those automated processes for building, testing, deploying software, and handling API integrations. The key benefit here is consistent, high-quality output delivered with noticeably faster response times.
Okay, so we've got the deep intelligence of Opus 4 for the really complex challenges and the speed and efficiency of Sonnet 4 for more routine, high-throughput tasks. But you mentioned both models also share this hybrid reasoning system. What's so revolutionary about that?
Yeah, this is a really fascinating aspect, I think, that sets both models apart. The hybrid reasoning system essentially gives them a kind of dual operating mode.
Okay.
On one hand, they can deliver near-instant responses, which is crucial for interactive applications where immediate feedback is paramount, like that snappy AI assistant we just mentioned.
Right, yeah, you wouldn't want your code completion tool to take several seconds to respond. That would be frustrating.
Exactly. But then on the other hand, when they're confronted with more complex problems that demand deeper analysis and strategic planning, the system can actually engage in more extended reasoning.
Fine.
It's not simply a matter of being fast or being thorough. It's about being able to intelligently switch gears based on the specific demands of the task at hand.
So developers can actually influence how much sort of cognitive effort the AI puts into a particular task. How does that work? Is it complicated?
It's actually quite elegant by adjusting what's referred to as the thinking budget.
Okay, thinking was.
Through token allocation, you can think of tokens as units representing the amount of text and processing the model uses. Developers can fine-tune that balance between speed and in-depth analysis.
Ah, I see.
And this level of control and flexibility is a pretty significant advantage. It allows for optimization based on the specific needs of the application. For instance, a quick code suggestion might need a smaller thinking budget for a faster response,
Right.
while analyzing a complex security vulnerability would definitely warrant a larger budget for more thorough investigation.
Okay, this all sounds incredibly powerful and versatile too.
Yeah.
So how do you actually start leveraging these models? We know they're on Amazon Bedrock. What are the first steps? Is it easy to get started?
Yeah, the integration with Amazon Bedrock is what makes these cutting-edge models so accessible, really. To begin using them, the initial step is just enabling them within your AWS account. It's a pretty straightforward process through the AWS console.
Okay, sounds simple enough.
Have been
And then
well.
how do developers actually, interact with these models? What's the programming interface like?
You interact with them primarily through the Bedrock Converse API.
Right.
This API provides a consistent way to communicate with the various AI models available on Bedrock, including both Opus 4 and Sonnet 4. The specific identifiers you'll need to reference in your code are, let me get this right, anthropic.claude-opus 420250519 v1.0 for Opus 4,
Okay.
and anthropic.claude-sonnet 4 20250519 v1.0 for Sonnet 4.
So those are the specific model IDs you'd plug into your application code.
Yeah.
You also mentioned the Converse API offers a consistent interface across different Bedrock models. Why is that such a big deal for developers?
Oh, that consistency is a huge win. It really is. Because it helps prevent vendor lock-in and promotes code portability. You can write code to interact with Claude, and then with pretty minimal changes, potentially switch to another model available on Bedrock if your requirements change down the line.
Right.
This reusability saves a ton of time and effort, allowing developers to focus on building their applications rather than wrestling with, lots of different API specifications.
That makes perfect sense.
Yeah.
Now, the information we looked at included a really practical example of using Claude Sonnet 4, building a Swift code reviewer. Can we maybe walk through that, see how it works in a real-world kind of scenario?
Yeah, absolutely. Yeah, this example gives a really tangible illustration of how you can put these models to work. So the code begins by setting up a client for the AWS Bedrock runtime, specifying the relevant AWS region.
Okay.
Then, crucially, it sets the model to that specific value for Claude Sonnet 4 we just mentioned.
Right, so it's explicitly telling Bedrock which AI model to actually invoke for this task.
Exactly. Now, the next really important part is defining a highly detailed system prompt.
Okay, the system prompt.
Think of this as providing the AI with its role and very specific instructions. In this Swift code review example, the system prompt instructs Claude Sonnet 4 to act like a senior iOS developer with extensive experience in Swift concurrency.
Wow. Okay.
It even outlines the precise areas to focus on during the review, identifying concurrency-related edge cases, potential race conditions, and ensuring the correct usage of Swift's concurrency features like actors and async await.
Wow, that's incredibly specific. It's not just a generic look for bugs command.
Not at all. And that's key. The more context and precise guidance you provide in the system prompt, the better the AI can tailor its analysis and deliver genuinely relevant feedback. The prompt even directs it on how to explain its reasoning and suggest concrete code improvements using modern Swift best practices.
So it's not just pointing out potential problems, it's explaining why they're problems and offering actual actionable solutions. That feels like a significant step up.
Precisely. So following that system prompt, the code then defines a simple user prompt, which is basically the actual Swift code that needs to be reviewed.
Okay.
It then initializes a conversation history, starting with this user-provided get.
Makes sense. The AI needs the code it's supposed to analyze.
Right. Next, the code configures the inference parameters. Here they set max tokens to 40 and 96, which limits the maximum length of the AI's response.
Okay.
And interestingly, temperature to minimal nero.
Zero temperature, what does that do?
A temperature of 0 essentially instructs the AI to be very focused and deterministic in its responses. It sticks closely to the most probable and, well, factual information. This is generally preferred for tasks like code review, where you really want accuracy and reliability above all else.
So no creative but potentially incorrect suggestions in this case. You want it to be strict.
Exactly. You want factual analysis. So the code then constructs the final input for the Converse API. This includes the inference configuration, the conversation history with the code, the specific model ID for Sonnet 4, and that really detailed system prompt. It then calls the converse stream function.
And streaming means you see the AI's feedback as it's being generated, right? Not just waiting for one big block at the end.
Correct. It allows for a more interactive and potentially faster experience, especially for longer reviews. The code then iterates through the streamed events, printing out the AI's analysis and suggestions as they arrive. And finally, the AI's response is added back into the conversation history. This is important if you want to continue the discussion with the AI, maybe ask for clarifications or further elaborations on its points.
It really highlights how crucial that well-crafted system prompt is for getting insightful and actionable feedback from the AI. It's not just about the model, it's how you instruct it.
Absolutely. It's a prime example of how providing clear, specific, and contextual instructions can dramatically improve the quality and usefulness of the AI's output. Garbage in, garbage out still applies, even with powerful models.
Good point. Now, before we wrap up, let's quickly cover the regional availability. These models aren't everywhere on Bedrock just yet, right?
That's right. Availability is still rolling out. Currently, Claude Opus 4 is available in the U.S. East region, that's Ohio and Virginia, and U.S. West, specifically Oregon.
Okay. And Sonnet 4.
Claude Sonnet 4 has a bit broader initial availability. It includes North America, same regions as Opus 4, plus several in Asia-Pacific, Hyderabad, Mumbai, Osaka, Seoul, Singapore, Sydney, Tokyo, and also in Europe, specifically Spain.
Okay, so depending on your location, you should likely have access to at least one of these powerful models, maybe both.
Yes, and importantly, both models support cross-region inference.
What does that mean exactly?
It means AWS can intelligently route your requests to the most efficient available region within your broader geographic area. This helps optimize performance and latency, even if the model isn't hosted in your primary region.
Good to know. And just to reiterate, you mentioned earlier that Opus 4 and Sonnet 4 are really designed to complement each other.
Exactly. Think of it this way. Opus 4 is your go-to powerhouse for those really challenging development tasks. The ones requiring deep reasoning, intricate planning, maintaining context over large amounts of information.
Right, the heavy lifting.
Yeah. Sonnet 4, on the other hand, offers that ideal combination of speed, efficiency, and still very strong performance for your more routine, high-volume workflows, where quick turnaround and consistent quality are really key.
So developers really have the flexibility now to choose the right AI tool for the specific job at hand. And the fact that they're both available through Amazon Bedrock's serverless infrastructure, that seems like a big plus. It means you can start experimenting and scaling your AI-powered applications pretty rapidly, right? Without the headache of managing underlying servers or infrastructure.
That's a critical advantage, absolutely. The serverless nature of Bedrock significantly lowers the barrier to entry. It lets developers focus on leveraging the intelligence of these models to build innovative solutions, not on managing infrastructure.
Okay, so to kind of bring it all together then, we've explored Anthropic's latest AI powerhouses, Claude Opus 4 and Sonnet 4, now accessible on Amazon Bedrock. Opus 4 seems to be leading the charge in AI-powered coding for those really complex challenges,
Mm.
while Sonnet 4 provides efficient, high-performing capabilities for more everyday development needs. Both built on this interesting hybrid reasoning system, and both readily available through Bedrock's developer-friendly platform.
And their potential to, well, revolutionize developer workflows by providing these incredibly powerful AI tools for coding, complex reasoning, intelligent automation. It's truly significant. It's not just about making current tasks easier. It feels like it's about unlocking entirely new ways of building software.
It really makes you think, doesn't it?
Right.
How could these advancements in AI transform your own projects, your own workflows? Are there currently time-consuming or really complex tasks that you could potentially streamline, maybe even fully automate with tools like these?
Yeah, and that raises an even bigger question, perhaps. As AI continues its rapid evolution, just at this incredible pace, what entirely new possibilities will emerge for how we even conceive of, build, and interact with technology? And what pivotal role will these sophisticated models like Claude Opus and Sonnet ultimately play in shaping that future landscape? It's definitely something worth keeping in mind as you explore the possibilities.